Welcome to the Science Salon podcast. I'm your host, Michael Shermer. Before I introduce today's guest, I want to talk about our sponsor, thegreatcoursesplus.com. The Great Courses, of course, is the teaching company generating lots of courses. I've done a couple myself, and I listen to them fairly regularly. The Great Courses Plus is their app that you get on your phone. You just touch it, looks like that. Boop, you touch it there. You get a whole host of courses that you can select from. Here's one that I thought was appropriate. Understanding the U.S. government. I think a lot of people don't really understand it. Starting with lectures like, why have government in the first place? So I'm going to start this course today. I'm guessing this has to do with Hobbes and Rousseau and all the early theoreticians about the social contract. And then lecture 2, the framework of U.S. federalism. Lecture 3 on civil liberties. And on down the line, how a bill becomes a law, why Congress is such a puzzle, how presidential elections work, and so on. This seems rather relevant. Anyway, I've been getting a lot of mail from my commercials I'm making here for them, since they're our only sponsor of the podcast, other than the Skeptic Society, of course. And that is somebody loves this lecture, they didn't like that one, or they tried this course and then they changed to another course. That's the beauty of the Great Courses Plus app, is you can just skip around, as opposed to just purchasing a full course on the teaching company website, in which you have the whole course. So you either listen to it or you don't. Here you can just bounce around. So give it a try. It's a free trial if you do it through us, through the Salon. So it's thegreatcoursesplus.com/salon, SALON. That's thegreatcoursesplus.com/salon. And you can get a free trial and bounce around and try it and see how you like it. All right, thanks for listening. My guest today is Don Prothero with his new book, Weird Earth, Debunking Strange Ideas About Our Planet. Starting with that one, that it's round, not flat. At any rate, I've known Don a long time. We met back when he was at Occidental College, and I started teaching there in 1990. Donald Prothero has taught geology for over 33 years as a professor of geology at Occidental College in Los Angeles and lecturer in geobiology at the California Institute of Technology in Pasadena. He's currently at Pierce College in Woodland Hills, California. He earned his MA, MPhil, and PhD degrees in geological sciences from Columbia University in 1982 and a BA in geology and biology from the University of California at Riverside. He's currently the author, co-author, editor, or co-editor of 33 books and over 250 scientific papers, including 5 leading geology textbooks and 3 trade books, as well as an edited symposium volume and other technical works. He's on our editorial board of Skeptic Magazine, but also a technical editor for geology, geopaleobiology, and the Journal of Paleontology. His biography goes on quite a lengthy span here. He is really one of the world's greatest geologists and paleontologists, and so it was really fun to talk to him about all the weird Earth theories, the hollow Earth theory, the flat Earth theory, the theory that the Earth is not moving, it's stationary, and the entire universe goes around it, and flood myths, and the myth of Atlantis, and throughout this conversation, as Don does in all of his books, I think the core theme is how science works. That is to say, it's not just debunking crazy, bad, fringe ideas that we all do in skeptics, and it's a necessary duty, but it really tells us how science does work. That is how we do know what's true. That is by falsifying bad ideas or wrong ideas, what emerges are the good ideas. That is what's left standing. So we get into all that and how science deals with anomalies and how anomalies like that grow into accepted theories and so forth. So with that, I give you Donald Prothero and his new book, Weird Earth. So we got the new book is Weird Earth, Debunking Strange Ideas About Our Planet. I love the cover. Show us the actual cover, because I didn't receive the final.
Here's the actual cover with the dust jacket, if I can get the glare off of it here. The dust jacket has a circular hole in it that makes the back art look like it's a round Earth. And then when you take off the dust jacket, it has art which shows, and again, the glare is pretty bad. It's the glare right off the computer screen, actually. Back it off. Maybe.
Yeah, there we go.
It shows that flat Earth, the water dripping off the front edge and the sun behind it. So that was a clever idea by someone, the designer team there in Indiana, to do that sort of send up. Of course, if you don't get it with the dust jacket or you get it electronically, you don't get the art.
So, but did they actually believe the water flows off the edge, or is the water held in by the Antarctica ice wall?
I've never read anything about how they account for that, but remember, they think there's an ice wall around the entire edge of the flat Earth that prevents everything from coming off the edge, and they don't believe Antarctica exists. Right? They think it's all fraudulent and hoaxing. If you hear reports of people who actually traveled across Antarctica, so you're dealing with some very serious weirdness right there.
Yeah, but you can take a boat to Antarctica. Do they just think these tour boats are just staring at the ice wall?
Yeah, basically that's it. They say, well, you can't see far enough into the continent to know that it's real. It's just an ice wall. And every scientist who's ever done it is obviously part of the global conspiracy and a hoaxer. And they say, well, there are no flights over the Antarctica. You can't fly from Antarctica from, say, South Africa to South America or whatever. Therefore, it doesn't exist. But the reason for that is that if you draw the shortest route across the globe, from, say, Cape Town to southern tip of Chile, or from Chile to say, New Zealand, you won't cross the Antarctic anyway, because there's almost no route where you would actually go across Antarctica. Plus, to fly across Antarctica for a commercial jet involves a bunch of other things. They have to take extra safety materials with them and things like that for landing in those conditions, which really reduces their capacity and increase their costs. So they don't do that. They basically stay over water, and it's still a great circle route. It's still the shortest route is to go following the globe around the corner to, for say, Cape Town to part of South America. There isn't any reason for them to cross Antarctica commercially.
Yeah.
There isn't. Of course, there are research flights that go there all the time.
What is your explanation for this sudden resurrection of the flat Earth theory, which is an old one, as you track in your book? I mean, was it just a kind of an internet hoax that took off as a joke, and then it became serious? Or
well, yeah, I think the biggest factor is the internet, right? Even as late as the late 90s, the only way that crackpots could hear from other crackpots were, mailing lists of these small fringe organizations. Like there was a famous flat earther creationist organization up in Palmdale here in California, and they had an old-fashioned mailing list, where they mailed little tiny homemade flyers to people, and that was the limit of their reach. And in the 90s, of course, you had Art Bell on coast-to-coast radio late at night, and that's where you could hear paranormal ideas. But again, the reach was very limited. You had to be a fanatic to want to stay up that late and listen to it, and most people never would encounter it in their everyday lives. But thanks to the giant cesspool of lies that is the modern internet, everything that's crappy is there, as well as good information, which is well overwhelmed by the bad stuff. And so, it doesn't take long for a person who's curious about flat Earth to go and start finding one crackpot site after another. And it's like a rabbit hole. Once you start doing it, of course, the search engines just divert you further and further into more and more of it. And there is no fact checking in this internet system, right? There's no way for you to be given a chance to recognize its craziness unless you yourself actively seek out some kind of debunking, which most people aren't willing to do if they're interested in the first place.
There's that documentary on Netflix about the flat earthers. It's mainly focused on that one guy. I forget his name now. And the camera crew follows him around, and they go to the conference. And
yeah, it's up in Seattle. I know what you mean.
Yeah, what's it called again?
Well, I forget his name, but he's up in Seattle or on one of the islands in Puget Sound where you can see Seattle. And he claims, the Earth is not curved because he can see Seattle from his doorstep. He lives in his mother's basement. Shows you what kind of guy he is. And he's a grown man.
But do you get the sense that a lot?
But the funny thing about these guys are that you watch the documentary to the end, of course, they end up discrediting themselves without having realized it. So they actually embarrass themselves and discover when they do these little experiments with the line of sight of a series of posts, for example, and try to show that it doesn't change it, that there's no curvature. In fact, they actually do show a curvature when they do the experiment right. And so they end up embarrassing themselves when they actually try to prove that they're right.
Right. Do you think they actually believe it, or are they just punking everybody, or it's just kind of a joke or just a fun idea?
I would say these people are true believers. If you watch them on TV and you read their writings, they've gone really deep down the rabbit hole. They're very serious about it. There may be some people who are into this just as an amusement, but I think it's, you're finding what's happened is that in addition to making it so easy for everyone to find this garbage because of the internet and then find each other, that's the single biggest factor that causes it to grow. The other thing is a handful of people who have celebrity, sometimes for no particular reason at all they have to do is say a few things, just a tweet or two, and they generate a giant firestorm of Twitter and Facebook and everybody else talking about it. That happened, of course. Tequila, whose reason for fame, I have no idea. One of these so-called people are famous for being famous. And then a few various athletes, including a couple of basketball stars, were doing this. And it just goes to show you that the public will listen to anybody, no matter how ill-informed and how poorly educated, just because they're famous. And that tells you the level they require. There was actually a battle between a rapper, the B.O.B. versus Neil deGrasse Tyson over Twitter and the internet, because the guy was trying to punk Neil deGrasse Tyson and poke him into response, which he did. And Tyson actually had his son compose a rap for him.
That's really funny. Well, yeah, Neil.
So they got that elevated. I would never think Neil deGrasse Tyson should waste his time on those people, but of course he is the public face of a lot of science, so it's a good idea, I guess, for him to get engaged in it. And then Shaquille O'Neal famously said something about that too, but then we are pretty sure now he was trying to punk everybody. Shaquille O'Neal frequently likes to do that.
Yeah, Neil's got the entertainment and educational chops to stand up to anybody, so it's actually good that he did that. Yeah, so, as you point out in your first chapter, our intuitions about nature are not well tuned to understand what it's really like. And I don't just mean quantum physics or string theory or expanding cosmos or whatever. That's obvious. We can't intuitively grasp that. But even the flat Earth and that the Earth moves around the sun, if you just stand there, it looks flat and you don't feel it move.
That's right. That's one of the things about science a lot of people don't realize. They often say, "Oh, science is just informed intuition, or science is just informed judgment and something like that." But it's really a lot about things that are not apparent at our scale of size and our scale of time and all the rest. Many of the things in science are so above our particular reference scale, so we cannot conceive really in any real sense of millions of years, right? It's a concept you can try to illustrate, but nobody really grasps it in the sense of a deep understanding of it. Or you can't really talk about the scale of the universe in any meaningful way. All sorts of illustrations, but people don't grasp it. And so, as you said, people have since the beginning of time always thought they were on a flat surface, looking at the sun, the moon, and the planets go around us, and that is the intuitive way. And it took a lot of people to make experiments and various types of experiments to show that in fact is not the case. The counterintuitive is often the reality once enough experiments and enough testing has been done to show that's true.
Yeah, I think it was Richard Dawkins calls that Middle Earth. Is that what he calls it, Middle Earth? In which we evolved on the plains of Africa to perceive things that are of a middling size, like from an ant to a mountain range, or they move at a middling speed from walking speed to maybe lightning or something like that. So things that are massively huge, like the expanding universe or a galaxy, or tiny like quantum particles or atoms or even molecules or whatever, we're just not equipped to grasp anything like that. And also I think, evolution, it's counterintuitive. You don't see species becoming other species. And and in this case, the Earth it
operates at too slow a time scale. So I was just saying it operates at too slow a time scale. That's why it takes a counterintuitive way to understand it and to recognize it. But then you go out and do the experiments and look for the evidence, and that confirms what we had already thought. You look at it today. There's lots of people who don't believe in viruses and don't believe in the coronavirus because they cannot see it. Okay, and yes, you can image a coronavirus, but again, they don't tend to believe what any authority tells them. So there's an element to that, to a lot of this denial of medicine that's, of course, not helping our country with all the people that are dying at this moment.
Yeah. some of that is just, I think, politically motivated anti-science, in which people...
Right. In the same way they're politically motivated not to believe in climate change or evolution as well. They're tied to a common set of beliefs in a community, their little tribe that doesn't believe this, therefore they don't either. And most cases, these people don't actually know why they don't believe these things. They don't believe in viruses. They don't believe in evolution. They don't believe in climate change. They just know the rest of their tribe does, therefore they do too.
Yeah, so there I often think that, it's typically Republicans that we think of as the party of stupid, that, they're anti-science, but, they're pro-science on everything that doesn't bump up against one of their religious or political ideologies. Right. And liberals, they can be anti-science when it comes to, say, GMOs and nuclear power, at least in my opinion.
Right.
And, a lot of those kinds of blank slate related human evolutionary psychology that bothers them. There's some anti-science there, but across the board, most people accept most science most of the time. So it's really how it gets targeted for people's personal beliefs.
Right. I mean, it's as Al Gore's title of his movie, An Inconvenient Truth, is very much appropriate to the thing. People don't want to believe what's inconvenient, which impacts their belief system, their lifestyle. They're happy to have expensive, fancy devices that make their lives easier, and they're happy, of course, they're alive because we have modern medicine. They didn't die in childbirth. They will take science for those things. But as soon as science tells them that something they don't want to hear, that's when you get the blowback. And when I teach this in class, or I've lectured on it a couple of times recently, the thing that stuns me, for example, and using climate change as an example, the people say, well, these people are all motivated to cheat and to lie because they're going to get big grant money, or something like that. And it's scary because it's laughably wrong. I mean, you can make much more money for an oil company than you can from, say, working in climate science or teaching like I do. But it's also scary that people could be so easily seduced into thinking scientists are so easily corrupted. I mean, we're some of the most hard-boiled, not accepting any dogma type people on the planet. And to get a consensus like we have, for example, over climate change or evolution requires enormous amounts of evidence to convince everybody but the most extreme crank that this must be the way it is. It's the evidence is what is behind it. And yet that scares me to see that society now has reached the point where they won't even trust, doctors or scientists when your life is at stake, just because of some ideology. So they won't trust doctors, including, unfortunately, a whole political party and their leader, just because it's inconvenient. And now people are dying because of that kind of mistrust of science and medicine. So it really has real-world consequences when people let their political beliefs get in the way of what they should be learning and should be understanding.
Yeah, I think, in fact, Al Gore's film, in part, bundled climate science with the Democratic Party or the left or liberalism, and therefore
it may affect.
And therefore, if you're on the right, you have to be against it.
Political in the film, but the message ended up being that way. Yeah.
Yeah, I think when it got bundled that way, that made it such that people on the right had to be against it just because Al Gore supported it. And, same thing. And that's the problem. If you give people, as I often say, a choice between Darwin and Jesus, they're not picking Darwin because, Jesus is wrapped up in their whole worldview and,
that's right,
and moral definition and, their beliefs about the afterlife and so forth. What has Darwin got to offer on that level? Nothing. Right. So you got to take that off the page. Just say, look, you can keep Jesus and Christianity or whatever you want. The science is true regardless. Think of it as God's way of creating diversity of life forms or something like that. Otherwise, it's an uphill battle. Although I should mention, I think since you and I have been at this for a long time, since I met you in around 1990 at Occidental, that I think we've kind of won the evolution creationism battle and maybe more largely the science and religion battle on that front, don't you think? I mean, you don't hear about those guys too often.
Well, certainly since the 2005 Dover decision pretty much ended intelligent design as a movement. I mean, the Discovery Center in Seattle is still going, but they don't try to push intelligent design as their front end of their type of attack. So intelligent design isn't being introduced anymore to various school districts, but we do know they basically just switched tactics to make themselves less obviously religious, because that was effectively the legal reason they lost every time, as it was obviously a religious dogma. And so what you're seeing instead is all these 15 years since the 2005 Dover decision, is individual states doing things like having their school boards do things to sneak in a little bit of creationism or challenge the evidence or discuss the evidence for evolution and against evolution, that kind of thing, where they selectively pick science that is inconvenient to them. And it's often both climate change and evolution these days that the school boards will often target and give basically an out so that individual teachers can then get away with teaching mythology rather than science in a science class. And so that is really where it's gotten to this point now. That, or they do other things like try to undermine evolution teaching in various ways. School boards, especially on the national level, but also local level. So if you keep up with the information on the National Center for Science Education site, it never ends, right? They're always battling another school board in another state that's attempting to push creationism down the kids' throats. So it's not gone, but it's been pushed off the front page by the crazy shit going on in Washington, D.C. So,
well, we do have a Department of Education that Betsy DeVos famously heads up now. And, she's fueled by a lot of right-wing oil money and so forth, and has other agendas. Fortunately, the creationism thing hasn't re-erupted there. But really, how much influence do they have, since it's really states or counties or local school boards that make those kinds of decisions on what exactly is being taught?
Right. Well, D.C. is a limited effect, right? The Department of Education, the Secretary of Education, the biggest way in which they can do things is to push funding for their particular goals. And so that's what she's been doing, is trying to find ways to channel more funds to private schools, especially religious private schools, so they can teach what they want, which they can since they're not bound by the same rules. So that's where she's interfered in the biggest. She hasn't tried to deal with the evolution debate on a national level, because indeed that is a state issue and a local issue usually.
Yeah. All right. So tell us, how do we know the Earth is round and that it goes around the sun? Give us the quick and dirty guide.
Start with the shape of the Earth first. And the challenge, of course, is that if you debate one of these people or even just try to talk to them, the first problem you've got to worry about is that their fundamental assumptions are different from yours, just like debating creationists. They don't believe the same things. They don't accept evidence. In this particular case, nothing that you could show them from the space program or from anything else is going to convince them, because they already believe it's a giant NASA hoax and everybody is on a giant conspiracy, which pretty much rules out all the evidence that would be most convincing to the rest of us, which is actually seeing the Earth from space, which now quite a few people have done, since quite a few astronauts, both from the original Apollo missions and now, of course, from the various space stations, have all been witnesses to. But it includes pilots who work at very high elevations. They say, oh, you can't see the curvature of the Earth out of your airplane. Well, you don't fly high enough at 40 or 50,000 feet to see it very well, at least not out of a small window in the side of the plane. But if you go to the pilot's deck, you can see the curvature of the Earth just fine by 40,000 feet. So it turns out you have to use mostly indirect evidence. They won't accept direct evidence. They won't accept stuff that people have photographed and stuff that people have filmed, just because they're already in a deep conspiracy mode of thinking right away. It goes from very simple things that go back like the 5th century BC, when the famous experiment by Eratosthenes showed that if you put a vertical rod and measure the shadow at high noon on the first day of summer in Alexandria, did the same at Syene, which is on the Tropic of Cancer, you'd find there was a shadow in one, and you can measure that distance and you can calculate the size of the Earth, which he did with almost 99% accuracy in the 5th century BC. But then there are other things as well. There's a whole bunch of experiments you can run to look at how things vanish over the horizon. So sailors in the days of Columbus, of course, knew the world was round. That's a myth that Columbus and his opponents didn't believe that. They all knew the world was round in the 1400s because they had seen ships disappear over the horizon and get smaller and smaller, which, of course, doesn't prove the Earth is round. But the fact that they disappear bottom first and then the top can only be explained if the Earth is round. If the Earth is flat, they would get smaller and smaller, and they would diminish in size, but you'd see the whole ship. But the fact that the bottom of the ship disappears over the curvature first tells you that it cannot be just distance. It's also a curvature. And then there are lots of ways you can do other things to actually see the curvature or in fact, see it whenever you have a lunar eclipse, right? The Earth always forms a curved surface as a cast of shadow over a lunar eclipse, which we just had about a year ago. And I had made a big point of being out there to photograph it and all the rest, although I ended up using a commercial shot for my book. But the curvature of the Earth is shown every time we cast an eclipse on the moon. It goes in a big arc until it's completely occluded. There's those evidences and many others as well. And then of course geocentrism is equally pernicious, because as we said at the beginning, when you sit on the Earth and look at it from the perspective of a human, you see the sun and the moon apparently moving over your head. And everybody until the time of Copernicus believed that. And even now we have a strange thing where there's a group of hyper religious, essentially creationist Catholics who don't accept the Pope and don't accept the official dogmas in the Vatican, which is odd, because you'd think the Catholics of any group would be able to accept their leaders' demands. And they are hyper-Catholics, ultra-conservative Catholics who believe the Bible is literally true, which you don't find the Pope preaching anymore. And they consider the Earth to be the center of the universe. And, of course, they pull that from Bible verses, which literally say the Earth is the center of the universe in almost so many words, which is ironic, because Protestant creationists never pull that thing up, because they know they'd be laughed off the stage if they do that. But anyway, getting back to this. So there's a group that called itself Galileo Was Wrong, .com. And they have had one symposium so far I know of at Notre Dame about 4 years ago, and may not have another, who knows. But anyway, they pull together all these weird misinterpretations of how you read the evidence in the solar system to try to establish that the Earth is in fact the center of the solar system. And so that's the way they work. And they don't seem to have quite as many adherents as flat earthers, which is interesting, because flat earthers seems to be more absurd than geocentrism. But they do basically appeal to the same things, very narrow arguments based on the fact that they can't perceive it in their world frame. Therefore, it does not exist, right? And then, of course, in their case, informed also by biblical literalism. So those are the kinds of things you see behind the geocentrists.
Yeah. And so how do we know that the Earth is going around the sun?
Well, you have a whole series of different kinds of astronomical tricks you can do, starting with really paying close attention to when the planets move and how they move. And you can do the calculations the way that, of course, Copernicus did in 1543, and establish that the only system that works to establish all those motions would be that the Earth moves around the sun. Of course, the thing that drove Copernicus to do this, it wasn't that he was challenging science or anything like that in the 1500s. It was the famous problem of what's called the retrograde motion, which is if you track a planet in the sky night after night after night, there are times when the planet will seem to stop, and then the next night it seemed to back up, and the next night it backs up a little bit more, and it backs up, and then it'll return to its forward path. And the reason that we're so familiar with the Ptolemy system of geocentrism, which was the one that, of course, adapted in Alexandria about 400 AD, the Ptolemaic system tried to account for retrograde motion by making the planets rotate on little circles around their path around the Earth. And those are called epicycles. Then that will allow them to be on a backward turn at times when they were doing it. And the reason Copernicus rejected the whole idea of geocentrism, again, was not because he had some beef with the Catholic Church or he was trying to disprove their cosmology. It was all about the fact that he thought the solution of having little epicycles, little loop-the-loops going on all the time, was too complicated, not elegant. And a lot of scientists will say that. An elegant solution usually ends up being the right one. And so he was the one who came up with the idea that if you just take the assumption that the Earth is the center and take it out with the sun in the center, then you explain retrograde motion very easily, because if this Earth is moving on an inside path fairly fast, a shorter path and also traveling faster, which it is, then any of the outer planets, it's usually Mars or Jupiter we're talking about, they're moving on a larger path outside of us, which is slower. And it's analogous to, say, going around the bend in an auto race, right? A car that has the inside bend is traveling fast and also traveling a shorter path. So if it goes on an inside bend around a car on the outside, the car on the outside may be traveling as fast as it is, but it'll fall behind because you're lapping it on the inside. So from your perspective as a driver, it looks like the car behind you is falling behind. But if you look on the outside, you'll see it's just they're traveling a longer path. And that is why you end up lapping on the inside bend your outside planet, which would be Mars or Jupiter. And eventually, of course, you pass them enough that you no longer perceive that sense, and then you start to see them moving forward again. And then you watch that NASCAR race, so they get the driver's perspective versus the outside perspective. You see a good example of that.
Yeah, that's often used as an example of Occam's Razor. The simpler explanation is the correct one. But usually, I think in science that's not the case. I mean, even in that example, even in astronomical examples, really circular orbits are less complicated than, say, elliptical orbits, or a straight Newtonian mechanical explanation of the planetary motions would be simpler than adding Einstein's relativity to, say, explaining Mercury's perihelion orbit. So really, being simpler doesn't make it more likely to be right. It actually, often, it's more complicated.
No, that's correct. Oh, yeah, that's true. And of course, for the level of detail that Copernicus had available to him in 1543, of course, that was sufficient.
Yeah.
And then, as we know, Kepler and others established their paths or their orbits are elliptical, and then Newton, of course, came up with laws to explain them. And of course, much has been added. So we always got to undergo refinement. And so, yes, it's not quite as simple as it was thought of as by Copernicus in 1543. But remember, we're almost 500 years later, so I think it's a pretty good guess for its time.
Yeah, for sure. Well, also, I think I've actually never studied what the Neo-Ptolemaic people think on this, but if you send a spacecraft from Earth to, say, Mars or Jupiter or even Pluto, it couldn't get there with the orbital trajectories that the NASA people create if it wasn't a sun-centered system, right?
That's right. Yeah. But remember, again, these people, just like the flat earthers, do not accept anything from an outside authority. They believe all the government agencies, including NASA, are a giant conspiracy. So you have the same problem debating them on that issue, because we have had satellites, of course, watch us travel around the sun, and especially the spacecraft we sent to Mars have looked back at us and watched us travel around the sun. There's a famous image that Carl Sagan had the Voyager craft do, one of the first to go to Mars, turning its image and its camera back at the Earth. And you could see the tiny pale blue dot that was the Earth. And that's where one of his famous phrases come out. A single pixel is blue. And then there's the sun, which is huge in that image. So that's been known since the first Voyager craft went to Mars. But again, you deal with that evidence, you're just wasting your time, because they've already ruled out that any scientific evidence coming from a government agency or a large authority like a university is corrupt, because scientists are corrupt, because we're all in a big conspiracy. That's the problem. You really have to go to all sorts of indirect, smaller lines of evidence to try to prove something like that, which, of course, for these people, no evidence will change their viewpoints. It's not about evidence to begin.
Yeah, so
it's about religion.
This is the problem with, or just conspiracy theories or anti-authoritarianism. If you can't test your idea, so it's kind of like we could apply the Popperian falsification principle to that. If they don't accept any counter evidence, if all counter evidence is hand waved away as fake, then they're really taking themselves off the page of even rational discussion. And maybe at this point we just apply what I call Hitchensdictum, that is, that which can be asserted without evidence can be dismissed without evidence. Goodbye and good luck.
Yeah, unfortunately, that's pretty much what you have to do. For these people, of course, there is no evidence that would change their mind, as it is with most creationists, right? As we said a moment ago, creationism is not about science at all. It's not even about evidence. It's about your salvation, where they're going to hell. And so you're trying to convince someone to accept, as you said, Darwin versus the Bible. You're not going to win that battle. So for people who are hardcore, there really isn't any point in debating it with them. And then when I write books about evolution, for example, I don't deal with that directly, because that's not something that works to make people think. The people I wrote my evolution book for, and I wrote this book for, might be people who are sitting on the fence, who have begun to learn that there is a conflict between science and what this cult says. And so that's why it's all laid out in the book as evidence for this particular viewpoint. Why do scientists all accept this without no real exceptions? That's because you really have a mountain of evidence. And if anyone's fair-minded, they can read that, and then you might reach that. The same as with creationists. When I've written books about creationism, mostly it's to convince the people who sit on the fence. And I usually get feedback when I get my Amazon reviews of people who just weren't sure what to think until they heard it read out very clearly. And one thing I try to do hard in this book, I do spend a fair amount of time debunking things and saying, this is garbage because of this, or this is garbage because of this. But one thing I tried really hard to do in this book was that it's scary now that people are supposedly educated by this supposedly world-class education system we have in the U.S., and in other countries it's happening too, but most of the U.S., are so easily swayed to something that's so sickeningly ridiculous. And it says a lot about the way we teach, that we don't teach them enough to make it so they would never buy into this garbage. But one thing I try to do in this book is say, okay, this is why we know they're wrong, and here is the scientific evidence. For most chapters, I spent the last third to more than half the chapter laying out a whole bunch of different kinds of independent lines of scientific evidence that say this is why scientists agree that this is the way the world works. That's really important. A lot of people, they learned the Earth was moving around the sun. They learned the Earth was round in elementary school, if not before, but no one ever told them why we say that. And then they get it back again, maybe in high school. They don't ever actually address the evidence. They're told facts they have to know. They spit it back on tests, and they never really grasp why do we understand this. And at college level, for example, and I teach a college level class in something of this sort, if I have the time, I will try really hard to give a few minutes, or at least, if not part of a lecture, explaining the evidence why we say this. Because it's more important to me that they remember and understand why we accept certain things as true and other things as not true from the evidence that we have been using now, in some cases for over a century. Then they just can spit it back a series of facts at me on the exam. I know high schools reward that, but at college, you go out to the streets and supposedly a college-educated person, you're supposed to know why. I mean, I think that's the ideal. I don't know it's taught that way everywhere, but that's my
well,
goal.
In educational science education circles, there's long been that debate about content that is just the facts of science versus process, how science got to those facts. And really, you need both. Of course, you got to know what the facts are, but how they got there, which is what I like about your books, is that, kind of little, because I am a historian of science, that, how we come to that consensus in the first place. I think part of the problem is the public doesn't see how the consensus is arrived at, and it feels like it's kind of an argument from authority. Oh, well, the IPCC says that this is what's happening with global warming. Why should we accept those guys? They're just a bunch of authorities. Isn't that an argument from authority? Well, what you don't see is the last 25 years of arguments and debates about how they got to that consensus, and all the people that dissented from that, and all the debate and disputation and peer review and arguments and so on. It's not like a democracy.
And the evidence, right?
What's that?
Right. I mean, they're authorities for a reason. First of all, they are educated to know something and they're talking from their expertise. They're not just blathering about something they have no expertise in. So, as you know, the argument authority is only an issue when the person is not really an authority. But if they are, in fact, someone who has the appropriate education and appropriate background, then you do, in fact, take an authority more seriously than they take a layman's opinion. And the more important thing, again, is what I was saying a moment ago, evidence, right? The experiments, right? People don't usually have the patience to actually listen and learn why we know something, but that's really what they should absorb as much as the fact itself. And so, as you say, it's always a challenge in education to decide how much time do you have to cover certain topics, and do you just leave a certain number of topics out in order to really dwell on one or two of these so they understand it deeply. And I have a challenge that time every time I teach any class about any aspect of earth science, because I end up teaching a lot of climate science and oceanography and meteorology these days, very far from my original training as a mammal paleontologist, but I've learned how to do those things. And one of the things I try to emphasize when I can squeeze it in, and it's always a matter of how much you focus on lots of facts versus lots of support. I try to put in that type of evidence. So or something that it really sort of beggars the imagination, like the Big Bang or the origin of the solar system or how planets formed, I do a little bit of the factual stuff, but I really do spend a lot of time giving them the evidence. Why do we know this?
Yeah.
And then in the book, I give an example of another case. We talk about, there's another group, a whole chapter on them called hollow earthers, who believe the earth is hollow, right? A giant hollow sphere, which seems absurd that anyone could believe that in the 20th century, but it came from, or in 21st century in our case, but it came from the 19th century ideas that these caves that they were just beginning to explore led indefinitely down to a big hollow end. And so, and then you have science fiction like Jules Verne's Voyage of the Journey to the Center of the Earth, which created this meme out there. So people have believed it for quite a while. So there's a big chunk of that chapter is devoted entirely to how we use geophysical data, especially the way seismic waves travel through the interior of the Earth and how the gravity of the Earth tells us what's going on in each layer and the magnetic field. All this stuff has told us a lot about a part of the world we can never get to because it's so incredibly hot and has such high pressures that no one can actually travel anywhere close to the center of the Earth. But we can say quite a bit about it with confidence because of evidence, because there's no other explanation for all the geophysical facts that point to a common type of pattern.
Yeah, it's good to know some history of science when you look back at how revolutions happen. First of all, the fact that scientific revolutions happen gainsays the argument that scientists never change their mind. Of course, scientists do change their mind when the evidence is good and the experimental evidence supports it. But if you look back at like the scientific revolution, this isn't over the weekend or even a few decades. This was centuries, from Copernicus, Kepler, Galileo, and Newton, and kind of the solidification of the Newtonian mechanical worldview. That took, over a century. And then you go fast forward to say Einstein, and he overturns just certain aspects of Newtonian mechanics with his 1905 papers. But even there, it wasn't really until 1920 that he became world famous because of Arthur Stanley Eddington's eclipse experiment in 1919. But so you're talking 15 years there where he's kind of toiling away as a nobody. And even in the scientific community, this comes out in the Einstein biography by Walter Isaacson, beautifully made into a 10-hour series, a drama on Netflix. Phenomenal. But just, this is Jewish science, or it's German science, or it's German Jewish science, or, all these kind of nationalistic forces at work. And a lot of his own colleagues didn't like him or didn't accept it. And, it really took quite a while. So, when people write...
Well, it was very radical. That's the reason. And the other reason, of course, was that they accepted that his ideas were worth publishing, but they withheld judgment on it until basically 1919 and later, because, again, no experiment had been done that would independently confirm what he had projected. And so that's the way scientists always have to be. We reserve judgment. We don't jump to conclusions. We accept it only after a lot of evidence has accumulated, and the confirming evidence is either disproved or proved it, but that's the way we're supposed to work it. So they didn't reject it all of them out of hand in 1905 or 1915. It was just considered an interesting idea that they could not figure out if it's right or wrong until finally scientific evidence came to support it, and then it became popular.
Right, and so people that send us these manuscripts in which they think they've overturned Newton and Einstein or whatever, they just don't understand how science works. It's not enough to just have an interesting idea. Anybody can come up with, half a dozen interesting ideas before breakfast, as we say. You got to actually have some, well, in this case, mathematics behind it. And Einstein toiled for years trying to get the math right. And that wasn't an easy problem to solve. And then you actually have to have some kind of experimental test to see if, to contrast it with some other alternative. Or else you can't falsify it. And if it's not falsifiable, then what is it? It's not science, or it's proto-science, or it's metaphysics, or it's something else, or just interesting ideas.
Or string theory.
Or what? String theory? Yeah.
Or string theory, which is at the moment still untestable, even though a lot of physicists take it very seriously. So,
same thing with the multiverse. I really like the idea of the multiverse, but that's to my own end because I'm always confronting theists about the origins of the universe, that sort of thing. And the multiverse kind of nicely explains the fine-tuning problem. But that's not why cosmologists are interested in the multiverse. They're using it as they're deriving it from predictions based on the mathematics or something, because I don't really understand that as a social scientist. But in the end, it's kind of irrelevant what I think or what you think or anybody thinks. There has to be some way to test it, or it's just an interesting idea.
Right. And science is full of a lot of those ideas. I mean, there's a lot of areas of science where we're still, starting to make this progress on their cutting edge. And we don't really know for sure if our speculative ideas are very correct or not. And yet we'll withhold judgment because we have to wait for this evidence to come in. Same way as in my previous book on UFOs. We don't jump to conclusions on anything we don't understand. Just because something hasn't been identified doesn't mean it is unidentifiable. we wait for evidence. And usually those things that supposedly UFOs always turn out to be something prosaic, like a spy aircraft at 90,000 feet, that kind of thing.
Yeah, let's talk about the age of the Earth and how long it took to figure that out. And then I always like that debate between the catastrophists and the uniformitarians. Because it seems to me that, if you put yourself back in time, it's obvious both are true. There are massive catastrophes, earthquakes and floods that do happen. We can witness those, and clearly they have some effect on the shape of the Earth and so forth. Right. And yet it's hard, again, back to our Middle Earth, it's hard to see slow erosion over the course of thousands of years, since we only live a few decades. Sort of walk us through, some of the ideas about that and how geologists currently think about those issues.
Yeah, the ideas really go back to the founder of modern geology, James Hutton, who lived in Edinburgh during the Scottish Enlightenment. And he started out, just being trained in a lot of things. He had a little bit of legal training. He was trained in medicine, as it was known back then. But he ended up making most of his money. Most of it was actually land he inherited his father. But he also had a business that created various types of salts that he learned from his chemical tricks. And then he would spend his life as an educated gentleman, hanging out with other brilliant individuals like James Watt and David Hume, and of course Adam Smith was one of his buddies. They all hung out in the pubs in Edinburgh about the same time in the 1770s, 1780s. And because he was a landowner, he started by looking at the way erosion happened on his properties. And then he would look at the rivers to which his soil was washing out to sea. Primarily, then the original purpose, of course, was to preserve his farmland. But then it made him think about how these things happen and how slow it takes for thousands of feet of sediment to erode into a river and then fall to the bottom of the ocean. And that told him it took a lot of time. And so those things added up for him. So by the time he reached late in his career and he was starting to write this up, he had realized that the traditional view of the Earth is only, say, 6,000 years old, simply couldn't work, because he saw these very slow, gradual processes happening. And famously, toward the end of his career, one of his last field excursions, he went out to a famous place in Scotland, which we went to on our 2016 UK trip, called Sicker Point, where you can see ancient sedimentary beds that are standing vertically. So they've hardened into rock after being horizontal. They've hardened into rock and then been eroded off on the top. And then there are new layers laid on top of those. And realized if they had happened at the rates that you see in the sediments coming into the ocean now, that this would have taken thousands and thousands of years at minimum. So the famous phrase from his theory of the Earth, 1788, is no vestige of a beginning, no prospect of an end. So there, in one intellectual leap, one person challenged the small Earth, young Earth version of the world and jumped us into a world where there was no limits on time. And his protege, in a sense, although they worked very different lifestyles, is Charles Lyell. In the 1830s, he published Principles of Geology, which pretty much brought Hutton's ideas into full acceptance by almost the entire scientific community. But at the time, Hutton and Lyell were dealing with this issue. The issue they were battling was called catastrophism, which you mentioned. And catastrophism is the idea that you have a supernatural event, like Noah's flood was the most common example, a supernatural flood depositing all the layers in this Earth and their fossils. In some cases, they would say that as well. And that supernatural flood was supposedly used to explain the whole interior of the Earth. So one of the things Lyell did, and of course he was a former lawyer who got sick of the law and did geology because it was interesting to him. So he left his barrister job and became a full-time not professional scientist, a freelance scientist he was in those days, was to beat to death the idea that anything supernatural and large scale could ever happen, which meant ruling out large floods because they were catastrophic, because they sounded too much like religious dogma. And so he was also a gradualist in that sense, not just a naturalist or not just a actualist who believed in modern processes and uniformitarianism, but also a gradualist. And for a full century after Lyell, most geologists not only accepted that idea, but they would never consider large-scale processes that happen quickly, even if they were natural, because Lyell had so tightly turned in actualism and gradualism into the same form of uniformitarianism. They didn't realize there's two components, right? Actualism is using modern processes to understand ancient ones, from actuel in French, which means living or modern, and the gradualism, of course, is looking for gradual change. And so that problem then was a problem in the early part of the 20th century still, because of the way Lyell had confused those two ideas. And so it turns out, of course, a famous man named J. Harlan Bretz, a University of Chicago geologist who worked his whole career in eastern Washington State, found these areas out there where the lavas had been all scoured by giant amounts of floodwater, and the so-called Great Scablands Flood, first published in 1925. And no one believed him for 30 years because giant floods sounded too much like Noah's flood. And that was against the Lyellan view of the world. And so it wasn't until he had ability to do aerial photographs in the 1950s for the first time that they went over the tops of these things and saw ripple marks of the size of buildings, that they realized, in fact, there were giant floods in the past. They are natural. They just don't happen on rates that are not gradual. And likewise, meteor impacts, right? Those are natural, but they're huge on scale, something we all recognize this, but that's not a gradual process either. So those kinds of thoughts have now sort of changed the way we do it. And then the parallel thread is as Lyell opened, especially Hutton, opened the door to thinking about time as huge, which is the hardest part in the first place, was the development of, in the beginning of the 20th century, of the discovery of radioactivity, leading to the discovery of ways to use radioactivity to date rocks. So by 1912, young Arthur Holmes, who had just finished his doctorate, published the first dates of the Earth that were more than 1 billion years old. And by the end of the 1950s, we had so many dates, we have pretty much the same time frame we have now.
Yeah, since you mentioned that massive flood in the Badlands, is it the Badlands or Scablands? In any case, Scablands.
Scablands.
So that brings up the Younger Dryas hypothesis about an meteor impact or comet impact or something 11,600 years ago. As you know, my friend Graham Hancock uses this as a possible explanation for the extinction of this advanced human civilization. But even taking that aside, the cause of the megafaunal extinction of all these North American mammals, huge mammals, which I often thought was more likely explained by human overhunting, since we do that kind of thing. But I don't know what the latest is on all that.
Well, the Younger Dryas event is around 11,700 years ago, and it caused the whole planet was just about finished getting out of the last ice age to suddenly chill down and go back into another ice age, or short-term ice age. And the prevailing evidence strongly supports the idea that what happened was that giant ice dams that were in more or less where the St. Lawrence River is right now were broken, melted, and released. Giant amounts of fresh water have melted off the glaciers from all these huge lakes that once covered northern U.S. and parts of southern Canada, and they put fresh water on a giant scale into the North Atlantic, which shut down the Gulf Stream. And the Gulf Stream is what brings the warmth all the way to the polar region and keeps it from getting too cold. And they shut it off for a while by putting freshwater lid on top of the salt water, and that caused this short-term fluctuation back into a smaller ice age that lasted for several hundred years. That part's pretty much accepted by everybody because the evidence is very solid for that. Now, the impact model for the Younger Dryas has a lot of problems, and there's only a small number of my colleagues who actually take it very seriously. Most say, first of all, there's not strong enough evidence of an impact in the first place. And secondly, even if it's true, it supposedly hits in the area of the Carolina Bays is the prevailing model. It doesn't explain things happening worldwide because it's not a big enough impact, nor is it the right size and scale. And then to the other component you were talking about there, the extinction of the mega mammals, almost all those date back to around 9,000 years ago now in North America and different ages elsewhere. So those are well past the time where we recovered from the Younger Dryas, and in some cases several thousand years after the Younger Dryas. So the Younger Dryas event is no longer even in the right time frame to have anything to do with megafaunal extinctions in North America or any continent. So the battle now among the people who talk about the North American megafaunal extinctions is over the causes. And of course, like everything in science, the answer is it's complicated. There's not a single right answer. And in this case, there's a strong lines of evidence that show that there are significant changes going on in climate as we finally pull out of the last part of the ice age and into the warm climates of the Holocene. Yes, it's likely human involvement is in some places, but there's some problems with that because we now know humans got to North America maybe as early as 16,000, maybe as soon as 18,000 years ago, which is a full 8,000 or 9,000 years before the mega mammals vanished, which is pretty much destroys any correlation there, and it possibly even earlier. And of course, they may have been up in Beringia and in northern parts of Alaska between ice sheets even sooner than that. So a lot of that has been given in a simplified form by the media. They love simple answers. Rock from space, dinosaurs disappear, right? That's not true. Or, humans humans arrive in North America, the mega mammals vanish. That turns out not to be true also. It may have been that there was a pressure of humans with Polson points and Clovis points to do a lot more damage around that time. Maybe their hunting patterns changed. That's possible. It's hard to test. But there's so many other confounding variables, it's not possible to know those. One thing is more important.
Yeah. One of my favorite examples of how scientists handle anomalies was when I was on Joe Rogan's podcast with Graham Hancock. The day we were on, or the week we were on, there was a paper published in Nature, which everybody knows is one of the top 2 prestigious journals in the world, about a find in the San Diego area of some mammoth bones that looked like they might have been butchered.
Oh, yeah.
And so, the scientists that published this, they said, they were just suggesting this is a possibility. They weren't concocting a whole new worldview, but they were, pushing that hypothesis, which would be, roughly an order of magnitude older than, the accepted dates for when humans arrived.
107,000.
Yeah, 130,000 was what
which is way early.
130,000, and now you were just mentioning 19,000 maybe is the oldest. Anyway, so before I went on, I asked Jared Diamond about this because he's tracked this, the kind of archaeological history of when humans arrived in North America, and there's always these new hypotheses put forth every few years. How do people like him handle that? So his response was, in response to that published paper in Nature, this is the latest semi-annual new paradigm pre-Clovis claim with a credibility half-life of 2 days. In other words,
well, it's funny because that particular paper, I know all the authors on it. They are mostly all friends of mine, although I didn't know they were working on this till it was published. But there's been a lot of challenges to it because the biggest problem in this particular case, the dating is probably right. The mastodon bones are probably where they're supposed to be, but the problem is it comes from a housing project in the San Diego suburbs. Rich Cerruti, the guy who collected it, I know pretty well. It could have been humans destroyed, but I don't think it adequately rules out the possibility that the fact that heavy equipment drove over this site many times before it was excavated and was found, of course, thanks to earth-moving equipment, that may also explain why they're fractured the way they are. I don't think that was adequately ruled out. So that leads me to say, okay, possible, but very unlikely when it comes to that idea. And I haven't seen any supporting evidence to rule that out since it was published. It's now several years ago at this point. So, what I always tell my students is that if you see it in the science media, it has about a half-life of about a couple of years. The more outrageous it is, the quicker it's debunked.
Right.
Because they'll say, oh, well, arsenic has been found in these bacteria in the hot springs up in the Owens Valley. And you find within weeks someone will have debunked it because it's outrageous what they're claiming. But most scientific ideas aren't quite that glamorous, so they end up taking much longer time for people to get around to doing the stuff. That's the way it works, and that's the way it's supposed to work. And what I tell my students is if it's published in a scientific journal and you see it in the science media, just take it with a grain of salt, because the only people who have actually tested this are the 3 or 4 people, if that many, that the journal asked to review it. And if those people passed on it, that's okay. But if it's a really important idea, it'll have a lot of people examine it for several years after it's published. And what the track record is like Jared was saying, is that most of these ideas that make the science media end up being wrong within about 5 years. So take everything you hear in the science media, because they're drawn to glamour, they're drawn to sexy stories that they're trying to grab eyeballs, right? So they always overhype things, they always overemphasize things. They always try to sell something, and the sexier the idea, the more likely to sell, but also the sexier idea, the more likely it's wrong. It turns out not to be true over the long run. So,
this is really, it's kind of a signal detection problem. How do we decide that the bones cracked in a certain way were done so artificially by humans or accidentally by moving equipment recently? See, and here in science where you can't quite make it out, like it could be, it's fuzzy, I can't quite see, let's just go ahead and err on the side of the super extraordinary claim. No, let's err on the side of caution and assume that it's probably not what we think it's going to be, unless there were a bunch of other finds. So here, even if it's a difficult signal to detect, if there were 20 more like this moving, say, up the coast of California, Oregon, Washington, in which it was 100,000 and then 90,000 and then 80,000 and so on. and it began to accumulate like, okay, it's entirely possible there were people here 130,000 years ago because we have these 20 other finds that kind of connect back to, say, Alaska or Siberia or whatever. This is the problem with an anomaly like that. It stands out, and here we can apply the ECRI principle, extraordinary claims require extraordinary evidence. You need to accumulate a lot of evidence before scientists would reasonably say, yes, okay, there's probably something to that.
Right. And that's generally the way science operates. When something makes the pages of Nature or Science and then shows up all the science media within a week after it's published, that's the first data point. That's the way you think of it. The first data point. It's not necessarily the final answer because there are going to be now numerous other scientists, especially if it's an important idea, that will go in and try to replicate it or try to find something else that either tests it and confirms it or disconfirms it. But they will examine a lot of other types of data. And that's why, I always say, just wait it out. The scientific community has a very good system of self-correcting and self-filtering, right? They know what they're doing, and the system is designed to basically weed out bad data. Even if it gets published in Science or Nature, it's still not done until it's been given 5 or sometimes 10 years, where it's really been looked at a lot of different people, and also other examples have either been found or not been found to confirm it. And that's when he shows up. So they say, oh, this will rewrite the textbooks every time they get one of these big explanations, sexy things on there. And as a textbook author, I'll tell you, I don't put it in the textbook until I've heard several years worth of stuff going on here. So like one of my competitors on Earth History book jumped the gun and put the whole, Carolina Bays, Younger Dryas impact thing in his book. And now it's had such bad shake, he took it out. I would never put it in the first place because it hasn't had enough confirmation to be taken seriously as a textbook.
Yeah, I remember back in the...
and that's the way it is. You don't rewrite textbooks.
Back in the 1990s, there was a...
Go ahead.
I was reading up on the Big Bang skeptics, and they were pointing out that there was some cosmological find or astronomical find where there was certain community of stars that were older than the universe. How can the daughter be older than the mother? And they're going, you see, the Big Bang is, it's not true. Anyway, I remember talking to Kip Thorne about this at Caltech, and he said, just wait. Probably, the error bars on the estimates are very wide. We need more estimates of the age of those stars. They're probably not as old as we think they are, even though it was published in a scientific journal. Let's just wait and see before we throw out the Big Bang. And sure enough, he was right. Of course, the refinement.
Sure enough, it's been debunked since then. Yeah.
Another thing I was thinking,
that's the way it is.
About reading your book was the. I think in the 90s there was a book about Noah's flood being explained by the flooding of the Black Sea, which was allegedly around the time of... Right,
yeah, actually one of my former professors. Yeah, that's well and good. I don't know how much it would be relevant, though, to Mesopotamia. It may have been the source of mythology that perpetuated all around Mesopotamia and all over the Mediterranean. That's a possibility for that. But it's really hard to know for sure what caused the Noah's flood myth, because it's coming from a culture, starting with the Sumerians 5,000-7,000 years ago, who experienced flooding on a regular basis in the Mesopotamian area, the Tigris-Euphrates rivers. They flooded sometimes several times a year, but they had gigantic floods several times a century. And if your entire historical record is written on clay tablets and your entire world is underwater for several years, in some cases of these really big floods, it will wipe out a lot of the memory of anything that precedes a flood. And it'll become permanently part of your cultural view. And then, of course, any historical records you might have had in clay tablets get washed to pieces, too. So that's probably just a simpler explanation. It's just an area that floods all the time. The floods are going to be a big part of the mythology. In fact, you see flood mythology in virtually every culture that lives on a floodplain. There's a few cultures that come from mountains that don't have floods in their origin myths. And that makes a lot of sense.
Yeah. Yeah, often I wonder to what extent we need natural explanations for apparently supernatural phenomenon or claims or myths. People periodically send articles to Skeptic. Like we actually published one, I think, in the late 90s, in which it was a claim that Jesus didn't actually die on the cross, that he was in a coma, and they gave him this drug that made his physiological processes seem like he was dead for 3 days, but then he woke up in the tomb and his buddies carried him off and he moved to France or whatever. It's sort of like a Dan Brown novel. But it was an interesting, attempt to, make a natural explanation for an apparently supernatural phenomenon. We get these two with this plague was actually caused by this thing over here, or the parting of the Red Sea was due to these geological forces or whatever. But usually I think maybe there's nothing to explain. Maybe they just made this stuff up.
Yeah.
And we don't need a geological explanation for X, because X was never true in the first place.
Right. And that's a big thing. If you spend much time reading the Bible in the original Hebrew, like I did, and in the original Greek in the New Testament, you realize a ton of this stuff is either mistranslated, or there's errors in it, or it's poorly translated, or the translation's ambiguous, especially in Hebrew, but Greek as well. And it's really hard to know what they really meant. And people who actually learn to read the scriptures in those languages are pretty honest about this. This is really, we don't know for sure what this is supposed to say, because these are the problems with the translation. Or we have older accounts that show that lots of this has been mistranslated or miscopied or cut down or added to. All that makes it so you shouldn't start with the assumption the Bible is literally true and you have to explain it. There's a lot of things in there that are simply just because of bad translation or bad errors or mistakes made in copying. And so all that stuff makes it so it's a fool's errand, because you're starting with the wrong assumption that you can take the Bible as literally true.
I often tell believers, too, that a lot of these stories have, moral homilies to them. They are moral homilies. They have moral messages to them. And that by trying to make them real, by trying to twist geology into showing that your story is true, you're kind of missing the point of the story. It isn't whether it's true or not. It's, what right. The story means. It's literature. It'd be like saying, Harry Potter actually happened. Dude, you're missing the point of the story. No, it didn't happen, but whether it happened or not is kind of irrelevant.
And you can look, for example, at the story with the evidence we now have how the Old Testament came together with the different sources, the priestly source and the Yahweh source and all the rest. They're different priests at different times in Israeli history that are different goals to prove. And so in many cases, they actually, like in this Noah's flood story, the J source and the P source are contradictory to each other, and yet they're interpolated verse by verse. They jump back and forth. And so that's why it has duplication all the way through it and lots of self-contradiction. But for those people, that wasn't the issue, right? They're not taking this as a scientific document, and they certainly weren't taking it literally. It was a document to instruct and to inform their people about the nature of their God and what the God demanded. And they didn't care that it wasn't literally true because it wasn't full of contradictions. That wasn't their point. It's only in our scientific world, the last 3 centuries and less actually, that people take things literally the way they do now. And that wasn't even an issue, even probably until probably the 1500s, that people started to actually take these things literally and read them that way. I mean, even St. Augustine were warned against taking the Bible literally and getting laughed off the stage, a famous thing he actually said on that topic. So, people have known for a long time the Bible's not intended to be literal. It's only in the last century or so that people try to do that.
Reminds me of that book, Black Athena, which we debunked in the 90s, claiming that the Greeks really stole Western logic and philosophy and rationality and so forth from the Egyptians, and the Egyptians were really Africans, and Africans are black, therefore black culture should get the credit for Western civilization. So I'm kind of doing a shorthand version of that. But Mary Lefkowitz, published a book debunking all this. But her point, one of her more central points, was asking what color or what race the Egyptians were versus the Greeks versus sub-Saharan Africans is a very late 20th century American question to ask, not something that somebody, thousands of years ago would have been thinking about or talking about.
Yeah. And the thing is, yes, there's elements. The Greeks certainly absorbed elements from the cultures that preceded them. Egyptian culture was dominant in the entire Mediterranean for a long time. So were the Phoenicians. The Greek adopted their alphabet from a version of the Phoenician alphabet. All that stuff is exchanging, but it doesn't go to the length that you were talking about there. So
yeah, it's so hard to read ourselves back into the mindset or worldview of people that lived so long ago. It's just inconceivable of how they would have thought of the natural world the way we do. which is why I always argue that it'd be fun to come back 1,000 years from now, be cryonically frozen and woken up into 2,500 or 3,000 or something, and to see through their eyes how wacky our ideas are about whatever string theory or fields.
Yep.
Back to Einstein, when he's talking about fields and his colleagues are fields, we don't talk about fields. We talk about forces. What's this field stuff? That's so old. And now we talk about fields pretty regularly. Maybe, 1,000 years from now, it'd be, what are you talking about with this or that? I can't even conceive of what it would be that we take for granted that 1,000 years from now, not that we were wrong. It's just that the way we look at the world or conceive of it is just so different from the way they will, or they did, thousands of years ago.
Yeah.
Which is,
how are we doing for time here?
We're good. Yeah, we're just going a little over an hour here. Let me just, wrap up with a few last questions here on.
Okay.
Really, so the myth of Atlantis. So you have a chapter on Atlantis, which is another one of these things. Plato wrote about Atlantis, therefore, and we trust Plato, therefore Atlantis must have been real. Now let's look to see where it was located. Whereas to me, I just think it's just a made-up story that has a moral homily to it.
Yeah, I think Plato definitely indicates that in both the dialogues where Plato mentions it. It's used as an example of a giant corrupt society, which the ancestors of the modern Greek society had vanquished, the ancestors of the Athenians at least. And of course, there's pseudo-history right away because Athens wasn't even in existence in the supposed time that this Athenian society beat the Atlanteans. But that was where it came from. And in both cases, if you read the two dialogues where it appears very much closely, you see he's just using it because it's already supposedly a quote from Solon, who was one of the lawgivers in the earliest days of Athens. And he is using it as an ancient myth. And so if it has any basis in reality at all, it probably stems back to the oldest Greek civilizations that they knew of. They had some knowledge of the world that Homer was a part of. And so there was, even though Troy was completely destroyed by that point, and a lot of other things that the Iliad and Odyssey are, of course, mythological, they were aware that there was a Greek culture before their own. And then several of those Greek cultures, especially the Minoans out on Crete, and the Mycenaeans and the mainland part of Greece, both vanished during the variety of events that happened during those times. So if there is any scientific explanation at all, it's most likely that the eruption of the Santorini or Thera volcano in the middle of the Aegean Sea caused tsunamis and so on that destroyed all the ancient cultures that the Greeks had some distant memory of. That would be where probably the myth of Atlantis comes from. And if that's it, that's all there is to it. That's probably all you need to think about. But of course, they misread it, and then they interpret it as literal, which almost certainly Plato did not intend. And then they can, from there, Atlantis has become a whole industry unto itself, right? There are movies after movies which quote Atlantis, and it's all over the paranormal literature. Atlantis is this, Atlantis is that. And first of all, for example, we know there is no Atlantis at the bottom of the Atlantic. Okay, that's the first part we can debunk right there, because the seafloor of the Atlantic is really well known, and there is no such thing as a civilized plateau that sank to the deep. It's got a very different shape altogether. It's also possible the fact that he's not even supposed to be in the Atlantic, because what they described as the Pillars of Hercules might actually be the 2 points that are on the bay that Sparta's on the south part of the Peloponnesian Peninsula. That would also fit the myth that Plato was using. So there's no reason to even look for it out there. And beyond that, there have been other candidates that are all Greek cities that vanished in ancient times. They are possible, but nothing so far as, giant civilization of super people living on the Atlantean continent and mid-Atlantic Ocean. That's completely beyond any evidence that Plato would have provided.
Right. Yes. Well, and then that it also taps into that desire for a golden age of when things used to be great, but now they're not because, we've sinned or politically sinned or whatever.
Yeah. Well, the irony was that Plato's original stories in both dialogues, the Atlanteans are given an example of bad people that the Athenians beat.
Right.
And the bank.
Yeah, so many of these stories are.
So they were nothing like modern mythology of Atlantis, where these supernatural good people lived. They were the evil people in the original story. So
yeah, so many of these myths have that element to them of a social commentary about their own times, like Nostradamus. It's trying to read modern history into some ancient text is always a big mistake. Well, Don, I know you got a hard out coming out here, so just kind of give us a wrap up of whether you're optimistic about the future of the acceptance of science. We're going through this science replication crisis, mainly in the social sciences and medical sciences. Of course, much of science is politicized and so on. You've been fighting this battle for a long time, most of your adult life. Where do you see us going in the future here?
Well, one of the reasons I wrote this book was that it was very discouraging to me. And first of all, I wrote a book about evolution creationism. Then I did one on UFOs, and I did also one on Bigfoot and other myths. So I've been battling all these various areas of supernaturalism, paranormalism, and strange ideas for a while. But this one came up, actually, as I didn't mention at the beginning, but it came up because I kept writing about it in my skeptic blog that you guys used to have posted. And so I had a lot of stories where I debunked this or that myth of the Earth. And one of the things, as I said, about this book, it's not just getting these stories debunked. It's trying to get at least the reader of this kind of book informed of why scientists know what they know, so that people aren't just carrying around a bunch of unconnected facts that they memorize but don't understand and therefore don't accept. If they have some kind of a weird idea come their way, they can't argue about it. That's what I wanted to first address. But as we said at the beginning, what's really scary is to see how now science itself is under attack anytime it verges on someone's set beliefs.
Right.
So we have a whole political party now that is deeply embedded in science denialism, especially originally just creationism and climate denial, but of course now medicine denial as well, which is deadly. It's not just a thought process that's not helpful. It's deadly that people are rejecting science and so on. I'm just optimistic that sooner or later, these bad ideas about science are going to end up being sort of purged from the country as the people who push them are no longer in power. Especially something like, say, denying and ignoring the evidence about coronavirus. That kills their own followers. It's not a very sustainable model for
Right.
any group to deny science when it's going to kill them. And yet what we're seeing now, especially just before the election, this is a week before the election, we're doing this interview, we're watching the spread among most of the people who have been the longest to reject simple things like masks and social distancing. So I think in some ways, once it shifts out of the political power issue and it becomes, when political people, the power is held by people who accept science and do what science is telling them is going on, we'll probably be better off. But it is discouraging that, thanks to the cesspool of lies on the internet, there's so many people who just reject science and reject medicine, and now to their own detriment.
Yeah. Well, Don, thank you for your work and congratulations on the latest book. What's next?
Well, I have another book coming out in a month called The Story of Evolution in 25 Discoveries. So it has 25 little vignettes about different ideas that have led to the understanding of evolution. It's all broken up in a little set of chapters, which is, I've got a series of books that say the 25 this or 25 that. So this is the fourth in that series. That comes out in November.
Nice.
And then partway through the summer, I was nearly finished writing a book on vertebrate evolution, which is going to be illustrated by this really, really amazing illustrator, Nobu Tamura, whose art is everywhere these days. And I got about 3 chapters and finished, and then the semester hit because I had to convert my entire curriculum to online teaching, which meant I had to start pre-recording in early August lectures for all 4 classes I was teaching. So all I do is I've got 300 students right now.
Oh, my God.
I'm buried alive in teaching till
That's crazy.
The Christmas break comes. So.
All right. Well, you hang in there, and thanks again for your work, and congratulations on the new book, Don. And we'll see you at the next Skeptics event.
Thanks so much for inviting me. It's great to talk.